reflections. And one way to keep track of reflections is by using this small graph here. I'm going to tag this right side as x, tag that as y because those are the x and y axis. I'm going to tag this one as negative y because it's the opposite side of y, and I'm going to tag this as negative x. Okay? Now, for example, if you have y equals to square root of x, and let's say you want to go through a reflection over the x-axis. Let's think about what we should do. What is the x-axis here? This is the x-axis, right? Now, if you flip that, reflection in 2D means it's flipping over like that, right? So the original graph is here, and what we want is we want to flip this like that, so the graph is turned upside down, giving you this. And what I'm trying to do is I want to find the equation for this. What should we do? Y becomes what? If you flip it over, what happens to y? Negative y, right? What happens to x? Nothing. It stays put, right? It doesn't do anything. So y becomes negative y. So we know that y has to be replaced by negative y equal to square root of x. And finally, you can solve this for y to get y equals this negative square root of x. Okay? So if the question was find the equation for the graph that's obtained by reflecting y equal to square root of x over the x-axis, this will be the answer. All right, let's do something harder now. Let me put an example here. Find the equation of, not the equation, find the graph. No. Find the equation of a graph obtained by reflecting y equal to x squared over y equal to x. Let's first draw the graph to figure out what it means. Here's y equal to x squared. It's y equal to x squared. Now you have y equal to x. This is y equal to x, right? What do I want to do? I want to reflect this graph, y equal to x squared, over y equal to x. So it's flipping over that way. Right? Trying to reflect something in the diagonal direction is actually very challenging for some people. One way to do it is maybe tilt your head to one side and try to see what happens if you flip over. Okay. Yeah. Or maybe tilt your head along this side and try to see what you should draw in order to make it symmetric. Now the resulting graph is like, it will be another problem because reflecting doesn't change the shape, right? It just changes the direction. Okay. Which direction would this parabola be opening up? To the right side. Okay, so the upside, this parabola is opening up, right? If you reflect over this thing, you get a parabola that's opening to the right. So you get this parabola. And what we are trying to do is we want to figure out the equation for this graph. Okay. Now let's go back to this picture that we want to use. Let's draw y equal to x here. This is y equal to x. Imagine flipping these y and x over this line. If you flip y over this, where does it end up being? where does it land? If this y jumps over this, where does it land? Y becomes x, right? If x jumps over this, when you flip this, where does it land? Y. So we see that reflection over y equal to x this means that x becomes y, y becomes x. Okay. In other words, if you had this flat paper and you took a stick and glued it over here, okay? And if you rotated that stick around 180 degrees, trying to follow where these x and y's land, this will go to y and y will go to x. They're going to interchange, right? So this is what you want, and therefore we take this original thing. Instead of y, what do you write? X. Instead of x, what do you write? Y. So that is the equation.